But before that, I want to turn this over to Lorenzo Mangani. Lorenzo runs QXIP, and he has developed a cool piece of software called CLoki. And I'm not going to explain any more because Lorenzo has got a great presentation and a demo, and we'll show you how it works. So Lorenzo, you're up. Yeah, Lorenzo, you're still muted.
Yeah, here I am.
All right, audio check.
Please confirm, is my screen sharing on?
Your screen sharing is on. You're ready for your cleared for takeoff.
Fantastic. So I would like to start with the thank yous, actually. Everything that you're about to hear me say exists because ClickHouse is open source and because Altinity does such a great job as, advertising his potential with his blogs and everything else, which we fed our knowledge from. So much of what you will see here, I assume, will be familiar if you follow, the Altinity blogs, etc. As said, today we're going to talk about CLoki, like CLoki, but like Loki, but for ClickHouse. So that's the best description of it, because it is basically a re-implementation of a PromQL client, namely Loki, on top of ClickHouse. For those that, of course, will not know me, I'm Lorenzo. I'm running QXIP in the Netherlands. We're an R&D company, and our specialty is really in the telecom market. So we have a pretty popular open source stack that is basically entirely dedicated to tracking VoIP, WebRTC, and et cetera, et cetera. It's all built on open source. This is our life mission, and why we feel so close also to ClickHouse. And we have a very lucky position, so we get to tap into a lot of real life scenarios. So we've been running this thing for about 10 years, and over this span of time we have seen it all, from the the voice monitoring perspective, which is just made of packets. It's as close as it gets. And since a few years, ClickHouse has been the engine of our dreams. We come from just about any other backend that you can think of for fast inserts, so we've tried them all. Just before ClickHouse, we were running our stack on Cassandra. It was a nightmare. I don't miss it at all. And we're here today because exactly of this application. But spending outside of what we normally do with ClickHouse, we entered the realm of logs, because even in the telecom environment, just like any other, there's a bunch of logs. About 20% of our activities, even with a pure telecom operator, are still log-based. When I say logs, they could be events, it could be anything, that gets dumped or emitted without a specific, data format. WebRTC is a champion of this. So browser, events, logs. If you want to trace what a browser is doing, like right now in this meeting, which is normally what we would be doing, it's a real pain because it changes every day. And ClickHouse itself is quite the log producer, right? So it's part of our life to deal with this. And over the course of our experience, we have tried pretty much everything, because our platform and open source is always about integration, in my opinion, if you do it right. So I come from the Elasticsearch community when it was a community. We had plugins for Kibana doing alerting. So this is kind of our passion, so to find the connecting spots. But many of those solutions just don't work for the specific use case that we were after. So everything that's offered as a service or costs a lot of money to run or does full text indexing against everything is just always too expensive. It doesn't scale. There's a bunch of backends that make it possible to get logs alongside time series, and they do a very decent job at the time series, but the log parts, it's really when it falls a little bit apart, because they're close but not so close. Just time series by themselves don't work. Custom solutions can be really awesome, but they come and go, right? So it's difficult to stick to something and invest into it if you really don't have a certainty that its support and its backend is going to be good enough, right? And a bunch of more things. Until at some point we saw Grafana doing something that we thought was interesting. So they came up with Loki, and of course, the point was to make it cheap to scale, to operate, and to use. But the thing that we liked the most, and that I liked the most, was that it was trying to make logs and metrics work together, which to me is really the innovation behind this idea. So for those of you that don't know, just a super brief introduction, they have fantastic stuff, so I don't have to do it, but what is Loki? Loki is a log aggregation system, very simple, let's say, on the outside, so it doesn't have a bunch of elements. The main trick is that it does not do full text indexing on logs. So it works with the same logic as time series. So it's going to index tags. So that's how we do the first skimming through the data, is by looking up only the text. So it's a very lightweight job that ClickHouse excels at, and everything else, it's an insert that's incredibly cheap. So we can throw a bunch of data at this thing and it doesn't even feel it. And it uses the LogQL query language, which is inspired by PromQL. And it's a language that we loved so much that we thought, it was worth investing into. They invest into a lot. So for all of you that use Grafana, you know what it is, and you know how much it's natively integrated. So a nice solution. It looks simple. So of course, I started using it. We plugged everything. We made our agents to send data into this. We integrated into our platform. And then, of course, inevitably, we started sending it ClickHouse logs, which is where things started going in this direction. So we're sending ClickHouse logs to this nice backend that's connected to Grafana, but what if we just swapped it with ClickHouse? This has started being like an obsession at some point, because it was so compatible with the power of ClickHouse and everything that we were doing with it that we just wanted to do it. So we grabbed our own certificate of madness, and we started, this mission. So can we take this API? Can we take this product and port it on top? So before we get into there, why should we even do it, right? Loki exists. I just described it. It's really nice. Why should we even try to do this? And the main reason is that we love ClickHouse. So ClickHouse is what we're using for everything. ClickHouse is what we want to use for everything. And this is just a good idea that was incredibly compatible with it. Then, in my personal experience, I don't know everything, but it's missing, the ClickHouse community is missing a standardized solution that we can just all use the same way and invest into without reinventing it a million times. And then a good idea is a good idea. And when you want to understand how something works, replicating it is a really good way to get deep into the subject. So there's already a ClickHouse data source for Grafana done by Verta Media. It's fantastic. I learned everything that I know about doing things right from it. Why don't we use that? The reason is that it's a plugin. So with this effort, I just wanted to make something that was native, that you didn't need a plugin for, that Grafana couldn't stop you from installing, that you didn't even have to install. So using their API makes it possible. And it's open source. And as much as I love, of course, the SQL of ClickHouse, it's difficult. I have 2 masters in my team that do everything for me. So I'm just lucky, right? I can just say, guys, how do you do that? And they explain it to me and they make the magic happen. But for the normal person, it's a pretty steep curve. So what was it about? Emulating the Loki API, recreating a LogQL parser, and then finding a way to apply to our tables. Luckily, we're sitting on top of ClickHouse. So, a lot of the things here that you will see are, and the intention is to create an API on top of ClickHouse here. We don't want to replicate something else. We want to take all of the things that we know work in ClickHouse, the best practices, just turn them into a usable language with 1 million users already, because Grafana, is that popular and growing. So everybody already has a client for it. Why don't we just make it work? And we did. So we rebuilt Loki on top of ClickHouse. This is a simple illustration of how it works. So we emulate the Loki API 100%. It's transparent. So it's everything, the plain JSON or protobuf, it just works transparently. It's 2 main pipelines inside of the application. One is dedicated to inserting the logs, and the other one to managing the labels. So managing the queries, caching them. So we optimize a lot, to make sure that we don't hit the database every time there's a query. So a bunch of stuff stays in memory, and everything else is bulked and then piped into simple tables in ClickHouse. Again, everything is designed to be transparent, so we can use PromQL, but I don't like PromQL. So we actually have our own agent. It's called Pastash, and it's very similar to what was discussed in Lightning Talk. So it's an agent that can take any input, transform it, send it to any output. So it can be used to parse logs, send them to ClickHouse, or read the output of a URL engine and do something else with it. So it works both ways. We use it to parse it, and inside the engine, everything is pretty simple because we want it to be simple. Again, it's ClickHouse that's doing everything here. We just made a smart, application on top of it. So this is made in Node.js with Fastify. It takes care of the API, protobuf, and everything else on the first layer. We have a smart system with LRU that's caching the fingerprints that we write and read to and from the tables. We have TTL-based rotation, so you can alter the lifetime of the logs just in a native way in ClickHouse. And then we have this wonderful LogQL emulator that Vladimir and our team have been working on for the majority of time, which again tries to make this transparent. In the middle of all of this, we also walk away with a few goodies that I will show you later. We can also use this language to query any ClickHouse table, and we can use any feature of ClickHouse. So this works with the S3 table engine. This works with whatever will be added in the future. Everything that saves us time or gives us performance will be native. How does it work inside? I just reassume the main two functions. So this is how a push of a Loki entry looks like. So you have labels that will be basically summarized in a fingerprint, and you have entries. Entries will be as many logs as these inserts will have. You can have many. This object can be more complex. So what we do at the entry point is we split them between our two tables: fingerprints, where we're going to do all the work in the lookups, and the other one, which is basically a very fast table where we can look up knowing already what we look for. Under the hood, this is how it looks. So it's native ClickHouse. There's nothing invented here. It's something that anybody can just understand, use. It's designed to be simple and stay simple. That's why it's actually fast. And as soon as we insert labels and values, we are able to use them immediately in Grafana. So we don't need to invent any client. We don't need to make anything. We don't need to write nothing. It just works right away. Here's my logs, type ClickHouse, filter them, last hour, done. In terms of querying, indeed, we entered the PromQL query language realm, which is quite complex, but we start with the simple layer. The simple layer is that we are going to use one or multiple tags to find something. So I want a DB, equal, or different, or that contains ClickHouse. We can use all of the filtering capabilities that you normally would have for JSON objects in ClickHouse. So everything that Robert is going to show afterwards is pretty much how this is done inside of CLoki to look up labels. After which we walk into the filter stage. So find me everything that has a label DB ClickHouse that contains the word click is basically what this query would do. The magic is that we turn this short one-liner into this wonderful, beautiful query. So we make it not a little, but I would say a lot easier. In this query, you would see quite a few techniques that we learned from the community, and that can be very easily, improved to quickly look up for the fingerprints that we care, and then using those fingerprints, go and get our data. Within this operation, we can do whatever we want. So we can go and do, parsing, regexing, and anything we know ClickHouse can do fast. Again, without having touched that data. PromQL is really extensive, so I'm not going to try to get too much into it. I'll just show you how it works in real life. Again, stream selector, filters, you will see it come together. This is an example query, and I'll show you some real ones if we have time. I'm trying to run. Type versip is going to return me logs that have this type of tag. Normally, it's just a list of logs. So this is just like, selecting a label if you are doing time series. What we can do is that we can immediately start applying filters. So find me all the logs with this tag that contain the word exit somewhere. And again, these could be logs, could be JSON objects, could be anything that you're dealing with in terms of data. Here's an example with ClickHouse. Let's grab the ClickHouse logs. Let's regex for the word reserving, which we'll find in the lines where we have memory. And then let's go and extract these from the log. So you can see here, it's a lot to digest at once if you don't know Loki, but we basically took this string, we parsed it. Well, we filtered it in ClickHouse, then we parsed it, then we extracted something from it that could have been an integer, a value, a float. We decide what is what, and then we use it. So this one-liner here takes the original untouched, unindexed ClickHouse logs, it filters them super fast with ClickHouse, it extracts a value that we care about, and it's projecting it on a chart all at once. And this works really, really fast. So it's you know, a Swiss Army knife tool, let's say, of slicing and dicing with data. This data could be anything. I mean, that was an example. We have a JSON parser inside. Same thing here. I can throw it some JSON objects, call them logs, but you know, they are what they want to be, and I can parse them and I can extract them. So this could be a simple or nested JSON object. We're just going to flatten it out and parse it so that we can go and say, okay, I have a class of objects that might contain a value that I want to track. In this case is WebRTC statistics, how many packets are being sent or received by something. And I can just put it in a query, extract it. So take my logs, parse JSON, extract one value because we want to be faster. And this, of course, again, it's using the ClickHouse features for dealing with JSON objects and so on and so forth whenever it's viable. Unwrap it to time series and show it to me. So we can go from a log that we're grabbing into displaying time series extracted from those logs pretty much in seconds. And in the process of doing this, we can discover data. So I'll show you a demo. I decided to switch it at the end. I just want to finish the logical talk here. So this type of queries increase in complexity, of course, the more the pipe extends, right? So the simple queries are served entirely by ClickHouse. They get the best performance. As we start extracting fields, doing matching, projecting into time series, of course, the complexity of the query goes up, but everything stays in a really interesting range. So here's a benchmark that we're running against the real Loki. So this is CLoki against Loki. We send the same data to both. We're running with, let's say, a cloud type of setup here. So we imagine something that's used, you know, as a cloud service, not necessarily local. So we have the two services in an equivalent setup. We send them the same data. We run the same query over time, and this is what ClickHouse is getting us. So we're, even with a, quite frankly, you know, still young and with much to be optimized application, we're burning some serious rubber with this. And we do it over time. So that's not a lucky shot. This is how it looks over time in our continuous tests. So our response for the same query, it's 2 to 4 times faster, mostly because, again, we're using techniques, queries, and hopefully formats that ClickHouse is really good at. And, you know, we're sitting on the shoulders of this giant that makes it all possible. So again, there's going to be things that are more and less similar. For instance, the math of time series right now does not yet take advantage of the new window functions. They're still or exiting experimental, but you know, these things go in at a very fast rate. And as I mentioned, that's not all of it, because we were talking about data that we have inserted in these you know, special tables that Loki or CLoki style has created for you. But what if you want to access data that you already have, right? So I already have data in ClickHouse that I'm writing my own way, wherever I want. He has a timestamp, he has a value, do something with it. And we can. So what we have implemented, since in this emulator we control the language, we have started extending LogQL to have some special queries. So this is how we make a ClickHouse query from a Loki in Grafana without Grafana ever even knowing that it's talking to ClickHouse. So as you see there, we summarize a few key parameters that we can use in multiple formats. So you can do the above query, LogQL style, or you can do the bottom one, which is more, let's say, explicit. So we select the database, we choose some tags that we want to use for group by. We choose a metric. This is a native function, so you can do any, you can use any function that you can use in ClickHouse. A where condition, interval for time, and it translates to the query that you see down here at the bottom. So again, another way to make a potentially, you know, tedious query simpler. This is exactly what the Vertamedia, you know, plugin will do if you use it with a different, a little more, let's say, LogQL style syntax. To test it, of course, integration tell the truth. So this is not like we've been working on this for over a year and a half now. So we started small, just with the logs, and then we went ahead, but we used it ourselves first. So we did the dog fooding experience. We implemented in our own application. We did an integration. We did back and forth. We provided it to our, you know, telecom market, which offers, let's say, a very spammy and noisy data generation environment, right? So a lot of data is generated, this is the type of environment where you're gonna read maybe 5% of what you're writing. So it's ideal for this role where we move the cost of the query to basically the end. There's no cost of insert, and if we spend anything, it's when we touch. So this passed our own exam, and then we went looking for other partners, and Zipfront is one of our partners. They run basically an automated testing suite for telecoms, just like you would do with like any service. Like they can generate 10,000 concurrent calls to a service or to a WebRTC or to a Zoom call or things like that, right? So they can generate a lot of fake clients that do things, and of course those clients generate a bunch of metric statistics, and they didn't have a solution for this. So we offered them to use ClickHouse and CLoki for this, and it took a week from a disaster and an incredible amount of confusing data into a system that makes sense, and that it makes sense in real time. So using those queries, they could basically pretty much automate everything without even knowing what data they should have structured. So completely bypassing, the typical part. Well, what do I do? Which columns do I send? Am I compatible? What if the client changes? With this, we don't care, because the queries, again, can change at the speed of data changing. So everything is super flexible. You get the same results, whether you're looking for, a log graphing solution or, something more complex. We have a pretty, quick evolving code base, but the roadmap right now pretty much is the following. So we're working on our plugin subsystem, where basically we allow our users to extend LogQL with external plugins, just like you do in a Node.js application. You can write your own function, throw it in the language, and use it without even us having to merge a PR. So it's an open ecosystem where people can code their plugins. Right now this is Node.js, but we have a Golang version as well in the works. We're going to start using the window functions for smoothing and upsampling the data that we get out. Right now we're bulky. We're moving fingerprints functions to be native to ClickHouse. This is because we want people to be able to write into the CLoki tables from any entry point into ClickHouse. So if you're getting your data from Kafka, you can make a materialized view that splits the data like we're doing. So it's going to write tags on one side and logs on the other. And the other part, the only part that's missing is the fingerprint being consistent. Live queries using materialized views. This is similar to what was in the Lightning talk as well in terms of concept. So it's getting the data when it's generated instead of running a continuous query. For this, we can have materialized views with a URL engine, which just yesterday we were suggested to use by Alexei the Great, and it works fantastic. Overnight, we made an alerting engine for CLoki. Async insert, semi-structured data inserts for JSON, and so on and so forth is basically what's on our plates for the next months. Hopefully by the end of the year, we're gonna have most of these things up and running. This is true, it's real, it's in production, you can use it. So actually, just to show you that we're not joking, this is the real example. So we're graphing for some ClickHouse logs in the first query that you can see up here. Then I can switch to filtering those logs and starting extracting some data. So I'm going and I'm asking it to generate a token label, which you can see here. This token label of 1 is extracted from here, right there and then. And then, of course, I can turn it into my nice chart. So this is my charts, looking at the data that I've just extracted in real time from the logs of ClickHouse, made with ClickHouse, using ClickHouse. It's a full circle, which is indeed what we wanted. And then again, the benchmarks and everything that I've shown you over the presentation is done with CLoki and using ClickHouse. So it's a fully circular system where we can generate data, look at this data, post-process it, and then of course use it. So the ultimate goal is not to do a technical job. This is the data. These are the queries that we can make in a dashboard that you can use however you desire and filter and do whatever you want. And again, the cool thing, in my opinion, is that we eliminate a little bit, or we change, let's say, the game in terms of entropy. Tags here are completely arbitrary. So I can choose what tags I'm going to use for my virtual time series. Here it is. Now it's an IP address. It can be any column that's available. That's a string. It becomes time series in front of your eyes as you change the query. And that's pretty much what CLoki and our work has been about. And that's all. Hopefully triggering some questions and discussions. But this is what we're doing, and it's on GitHub. It's you can host it yourself. You can do whatever you want. It's all there. It's really easy to run. We suggest to run it on top of a ClickHouse instance, being pretty much an API on top of ClickHouse. The closer it is to it, the better it works. And yeah, we're curious what people are going to make of this.
Hey, Lorenzo, great talk. We've already got one question lined up, and I'm sure there'll be more. Here's one from Graham. Can you look for log entries subsequent to a match? Like, suppose I know an application is throwing a stack trace, and I want to see log entries with parsing exception, and then the next 100 lines from the log, even if those lines don't match a pattern.
Yeah, sure, it's possible. And if it's not possible to do it directly in there, again, this language can be extended. So, you know, it opens up the way for having it do whatever we want, as long as we have the data, right? So it could, right now, well, I would have to show you, but, you know, queries can be simple or complex. So what we just described is totally plausible. We also have our log processing pipeline, as I mentioned, where we can prepare the data for, you know, making these type of things easier, namely tagging it well. So if we tag data right, it becomes really easy to, you know, make those type of decisions and create chaining filters and pipelines, etc. So I would say one of the conditions to that being possible would be to have decent tags for the logs.
Okay.
This is, by the way, our tool Pastash. It's, again, a Node.js application. You just install it with npm. You configure it with a recipe like this. You can point it at a log file, at an event socket. It can open sockets by itself. You can listen to Kafka, RabbitMQ. We have a bunch of inputs and outputs, including decentralized ones, Hyperswarm, BitTorrent, anything you want. It can take data, parse it, transform it, you know, add, remove tags. It's like Logstash would be to Elastic in that case. And then you can send it anywhere you want. So in this case, I'm using it to send it to Loki, our Loki, or it could be the real Loki, or it could be another backend. So we keep things pretty open. I mean, the spirit here is open source. So none of these things is made to be exclusive, but rather to be very easy to plug, whether you're using ClickHouse as a source or as a destination or both.
Great. Yeah, I have a question, which is on a somewhat related note. Can you talk a little bit about the underlying schema that you're using inside ClickHouse to represent this data?
Sure. Let me go back up here. I think I have it. Yeah, pretty much.
Okay.
This is a good example. So keeping it simple is the trick. And again, we're splitting data. So we're not writing everything in the same tables. We have a table that's exclusively dedicated to fingerprints. So in this table, we have a group of tags equal fingerprint. And this is the only table where we do actively search when we do the first layer of filtering. So in this fingerprint table, very simple, timestamp, fingerprint, and JSON object. The JSON object, I imagine, is accessed exactly as you would, you know, using standard functions. So we can extract all of it, just some fields, look through it in various ways, depending which one is the fastest. And this is how we do the first selection. The second table, as you can see, is really, really simple. And this is really, I mean, much of the trick is to keep it simple. So we store fingerprint, timestamp, and either a value or a string, because CLoki actually can also be used for metrics. I'm not promoting it as its primary role, but you can send it Prometheus metrics or InfluxDB metrics as well. It writes them in the same table with the same logic. So everything that's a tag goes to the left, fingerprints, everything that's data goes to the right. The only identifier, the only way that we'll find this log is through its fingerprint in the life cycle of Loki and CLoki. So we only ever search using fingerprints, which allow us to select those, you know, 50,000 logs that we care about really quickly without ever looking into their body until we know that it's of interest. And then in the pipeline, we can do, you know, make the job more complex. So we can pipe this query into further queries, but this is the data schema. So it's really, really simple.
Okay, great. Yeah, and there was a comment from Alexander Dubovnik. Alexander, do you want to be
Oh, he's
unmuted
one of
so
our
you can
team.
talk?
So,
Yeah. So
yeah.
here, Alexander, just a second. Let me unmute you. And
he's our
yeah,
ClickHouse guy, so I'm happy
go
to...
ahead and feel free to comment directly.
Hi.
If you,
Okay, great
welcome.
talk, Lorenzo. Yeah, thank you for this exactly possibility to talk about CLoki and say again what ClickHouse is a great database. It's very, very good. And we are very happy to be part of this community and make something bigger. So, and about what just want to add about what Lorenzo already said, because we started with schema, it's very simple. Because before it's with JSON, data type didn't exist, yeah, was not exist in ClickHouse, and exactly Alexei Milovidov announced it a couple of days ago that it's now a JSON data type can be exist, and the JSON packet can be structured, semi exactly structured and split it on disk, and in this case, it will be around 5 times faster to extract JSON text from disk. So it's just exactly my comments here.
Indeed.
Great.
And again, in our wiki, we have the entire set of information in case anybody's interested. Here we described in the wiki everything, how we do it, how we create tables, how we write into them, how we select from them. So the entire thing is fully transparent. And again, it's so simple that I think, you know, it can probably be mastered in 10 minutes.
Yeah, and I noticed one thing, you're just doing raw, you're not doing anything special. You don't have any secondary indexes or anything like that. You're just doing raw scans on this.
Yeah, but
well, it depends. It depends on it depends on actually the preference. So in this, again, for me, what's important is to have a low entry point. So all of these optimizations, you know, much of them, we have them branched and we have them left and right. But, you know, the entry point for this explanation is the simplest one. It can be made as complex as you want because all of the create, all of the queries, etc., can be modified. So none of this is hard-coded into CLoki. It's just templated. So it's clearly a templating API on top of the native functions that one might want to use. So all of the optimizations are totally open. You know, part of our job is, of course, to help people take this in the direction they want and with the performance that they want. So we leave something to be created with this.
Yep.
Yeah, and Robert, you're absolutely right, and especially here, because we can make this secondary index optimization with Bloom filter, you know, with JSON, with data, and also you can use token index, yeah, which will exactly speed up search to light speed. Yeah? So it's many ways to do it. So we know everything, and it's in our roadmap. But even without this optimization compared to Loki, we are winner. Yeah.
Yep.
And it's, thanks,
yeah, well, ClickHouse is doing so good that even without, and again, those are just examples, not necessarily you know the best query you would find, but you know, ClickHouse is doing so good that even if you don't try to make it do good, it still beats the competition.
Yeah, and then what's the largest amount of data you've put into this in the past? Like billions of rows, or what's the?
Yeah, well, look, I mean, here you can really compare it to any other, you know, stress test case that you have because of the inserts being so simple. So since the inserting pipeline is such simple, it compares one-to-one with the benchmarks that you normally would have. So yeah, in our, I don't think we used it to store, you know, terabytes of data ourselves, but we have pretty intense setup. So our attention is mostly on how much data we can insert at once rather than how much global. And then again, it works with the S3 buckets and so on. This is still early being tested, but I think that's where a good majority of the users of this might actually want to take it because that's the cheap way to do it, really.
Yeah.
Great. I want to make sure that if there are any other questions, please feel free to queue them up. And Lorenzo, I know one of the things that you guys would like to do is you'd like to make this a generally maintained project. I think there's clear value to what you've done. So you're also, you know, you're also looking for additional contributors. Is that?
Absolutely. Contributors, users, testers, and contesters. So right now, what this idea needs is a little bit of community around it. This could take it to the next level. there's interest, of course, from a functional perspective, from a feature perspective, and from many other perspectives. But really, it needs users, just like anything. So our hope today is exactly to, get the word out, and if even 1 in 100 people, joins us, this is how we made our team. I mean, we're all volunteers, we're together because we love this, and we want to do it with ClickHouse so bad that we actually succeed at it because we're so stubborn. So other stubborn people, feel free and welcome to join us anytime. This is really an open group, and actually we're looking for ideas. I mean, there's no possible way that we can figure it all out by ourselves. So we have a nice platform. We made it extensible. We made it open. Come and hack it with us.
Thank you very much, Lorenzo. That was a great talk. Really, really appreciate you presenting today. Oh, here's a question from Catherine Johnson. Are there any limits, upper limits on label sets? In other words, cardinality?
Not yet. Also because, again, we only work with subsets. So we expect those to be, so let me shrink it down. If we extract them efficiently, no, there is no limit. So we have tried this. I mean, that's the part that actually I am trying to fight the most. We try to do this with other platforms, and it always fell because of that. We deal with public internet. So we have IPs, random identifier. Each WebRTC session will generate 10 UUIDs, and they will all be part of tags. And this is where any other system was exploding, and this one is not. So there is a limit always for everything somewhere. We haven't found it yet.